Hello YouTube, this is Umozo3. In the previous video, we reviewed frozen dictionaries and we talked again about this class that we implemented. Basically, we implemented a class in order to basically define a collection of key value pairs that's immutable. Okay, so we do that with a frozen dict class. And we have a constructor for it, and we basically just define a frozen dictionary by a dictionary. So we say self.dictionary equals my dictionary, just like we implemented stacks and keys with a list, right? And then we could get the length of the frozen dictionary given by the length of the dictionary on which the frozen dictionary is based. We could get an item, get a value out of a frozen dictionary by sticking in a key, as long as the item is in self.dictionary.keys. Otherwise, we would return the string not in the dictionary. And the get method works the same way, right? We could call either x of y in square brackets, or we could say x.get of y with parentheses, right? But we're not allowed to set values in a frozen dictionary. We're not allowed to add or remove key value pairs, and we're not allowed to modify the values that are currently assigned to existing keys, right? And then we could also have a string representation of a frozen dictionary, return f, the f string, self.dictionary. And then how do we see whether an element is contained in the frozen dictionary? Well, we would return a valid item in self.dictionary.keys. So we would be looking in the keys to see if that item is in the key set. And then we could add two frozen dictionaries together. We talked about that in the previous video. So new frozen dict equals dict for k in self.dictionary.keys. New frozen dict of k equals self.dictionary.get of k. For v in other.dictionary.keys, if it's not the case that v in self.dictionary.keys, new frozen dict of v equals other.dictionary.get of k. Q equals new frozen dict of Q equals frozen dict of new frozen dict to return Q. So it just returns a new frozen dictionary. It just returns a new instance of the frozen dict class where we have all key value pairs from both frozen dictionaries, except if the second frozen dictionary had a key that the first dictionary already had, in which case we would not add on that key value pair because we need unique keys in a frozen dictionary or a dictionary in general, right? And then we could see if an element is contained as a value in the frozen dictionary. So the contains value method returns true if value is in self.dictionary.values. Then we have a class method and a static method respectively to produce a new frozen dictionary. It just makes a call to the constructor either on line 55 for the static method case or on line 61 for the class method case. And then we have a subclass on line 64. So class callable frozen dict of frozen dict. So it's a subclass. It gets all the same stuff from the superclass. So it gets the length magic method, it gets the add magic method, it gets the get method, okay, but it also has a call magic method, so call of p. And so if p is in tuple of self.dictionary.keys, return self.dictionary of p. Otherwise, return the string. That key isn't in the dictionary, right? And then we can go ahead and review what we had in the previous video. I think we've already talked enough about iterators, so we can probably go ahead and skip a little bit of this, right? But we could say define JSON object of S. So again, we've been talking for several videos now about how there's a JSON module and it supplies two functions, loads and dumps. So loads accepts a string and returns a dictionary. Dumps accepts a dictionary or a Python object in general and returns the JSON string representation of it. And that's what we do on line 146. We say JSON string is a lambda function that accepts a W and returns j.dumps of W. And the reason why we call it J is because on line 1 we said import JSON as J. So we've been talking more recently about how not only we can import a module, not only can we import a certain function from a module, not only can we import a certain function from a module and call it something else, but now we can just import a certain module and call it something else. You just say import JSON as J. So hopefully that's clear to you. But we say my dictionary equals and then map A to 95, B to 85, my number to 85, and 84 to 85, right? We've already seen examples of this in the previous video, but length of my dictionary, well, after we do JSON object of my dictionary, we just get 4 because there are 4 key value pairs in that dictionary. And then my dictionary.update of C was 75. Well, that would give us this frozen dictionary, or that would just give us this dictionary, right? And then my dictionary of D is 65. That would give us this dictionary, right? And then we could say for Q in my dictionary, if my dictionary.get of Q equals 85, print Q, and then we don't see my number, right? Because even though my number had a value of 85, it was popped from the dictionary. So that's why it's not printed on the console. right? And then we could also try the JSON string. So S1 equals S2, S2 equals 8284, S3 equals 100 times S2 minus S1, S3 equals JSON string of S3, print length of S3 concatenated with S3. So that will give you a 6-character string, right? So hopefully that's clear to you. And then and then we could say print length of my dictionary equals length of JSON string of my dictionary. Clearly that's false. And then A equals 323, print type of A, that's a tuple, but print type of JSON string of A, that would be a string. And then we could say exec of Z equals, this is a very, very long value in a very, very short dictionary equals 2Z. Print length of short dictionary colon equals JSON string of short dictionary. Well, that would be false. And then we can try out our frozen dictionary method, right? So dictionary T equals 1, bool of 1, 0, bool of 0, potato 5.75, 5.75 tennis, soccer tennis. Print length of dictionary T, well, that would give us 5, right? Because that's calling the magic method, right? That's calling the magic method length that we specified, right? So that would be the 5. And then print dictionary, well, I guess that would not be the magic method. So these are just for the regular dictionary. But then on line 187, we say frozen dictionary T equals frozen dict of dictionary T, and then print length of frozen dictionary T. So that's why we get the 5, right? And then print frozen dictionary T of float of 5.75, tennis. Print frozen dictionary T dot get of soccer, again, tennis, right? And then print potato in frozen dictionary T, well, that's true, but print tennis in frozen dictionary T, that's false, because we said our contains magic method returns true if we have a key in the frozen dictionary, not a value. Okay, and then we can add 2 frozen dictionaries together. We've already seen examples of that. But then we talked about this callable magic method, right? We talked about callable and the callable function. So frozen dictionary Y equals callable frozen dict of 9 with 90, 7 with 70, and 5 with 50. And then print frozen dictionary Y of 9. Well, that would give us basically, that would give us 90, right? So that would be the 90 that's right here, okay? That would be the 90 here. But then frozen dictionary Y of 4, well, that's calling the call magic method of the subclass. It's not something you can do with frozen dictionary X or frozen dictionary W, because those are instances of the superclass, which does not have a call magic method, but the subclass does. And that's why we say print callable of frozen dictionary X, false, but print callable of frozen dictionary Y, well, that would be true, right? So hopefully that's clear to you. And then print callable of map, that's true. Print callable of float, that's true. Print callable of print, that's true. But W equals 177, print callable of W, that will be false because an int is not callable. And then we talked about hex numbers, so define hex numbers. So basically we're talking about hexadecimal numbers that go up to base 16. So you don't just have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So print hex of 5. Well, then that would go ahead. I guess I'm not really calling the hex numbers function anymore. So let me just call, there's some more things there's some new content that we want to talk about in this video. So I want to leave at least eight or so minutes to do that, but I'm just going to go ahead and scroll back up. So we say print hex of 5, and that gives us 0x5, because we said 0x will always show up as the beginning of the result of any hexadecimal number. And then print hex of 30. Well, basically 30 is like 16 plus 14. So that's why we get 1e, right? Because the 1 is for the 16 and the e is for the 14. And then we can say h equals lambda x defined by hex of x. So now h of x works the same way as hex of x. We could have also said h equals hex, but exec of print of h of 892. So that would give us 37c, and we talked about that in the previous video, right? That would be like 3 times 16 times 16 plus 7 times 16 plus 12, and that would be 892. And then we can also take a hexadecimal number into an int. So we could say print int of 0x55, that gives us 85. Print float of 0xf3b, well, that gives us 3899.0. We can convert a hex into a float basically by first converting it into an int and then converting that int into a float. And then print length of string of 0x2b, well, that would give us 2, right? Because I think in the previous video we just did print string of 0x2b and we got 43, but 43, that's a string that's 2 characters long, so that's why it says 2. And then print bool of 0x00, that would be false because 0x00, that's like a 0. But print bool of 0x01 would be true because any hexadecimal number that's not 0 would return true, right? And then print type of hex, well, that would say it's a built-in function or method, but print type of h, that would just say function. Print callable of hex, indeed, hex is callable. So hopefully that's clear to you. What we're going to do in this video is we're going to talk about ASCII values. So basically there's a character encoding. And if you've already watched my Java curriculum, I do have some videos about the character data type. And we're thinking about a data type that's only capable of holding one character, whether it's a lowercase e, or the number 4, or lowercase p, or a capital K, or an open parenthesis, or a space, or a $sign, or an exclamation point, or a capital Q. There's a hell of a lot of letters and characters that you can see on your keyboard. And you know, the up arrow and the percent sign, you can just look at all those symbols on your keyboard, and all of those has what's called an ASCII value, a character encoding. So what we're going to do is we're going to think about two standard functions in Python. So we're going to think about ord of x accepts a character x and returns the ASCII character encoding. And so this probably amounts to a Google search, and we can study this, but there's a whole Wikipedia article, and you can see I've already Googled it a little bit. So we just go to ASCII. So ASCII, it's a character encoding. It's called the American Standard Code for Information Exchange, okay? And so what you do is you can understand that different characters have different symbols associated with them. For example, the capital P has code 80, okay? The capital T has code 84, okay? The lowercase f has code 102. The lowercase x has code 120, okay? There's different numbers here. If you're looking on Wikipedia, there's probably easier ways to read this list. There's probably websites that will have a less confusing representation of this, but you have to look in the decimal, okay? So we want to look in the decimal category. So in this light blue column, and it just tells you basically a character encoding. So it's like a number that corresponds to each of the characters on your keyboard. And so basically what we're going to do is we're going to study a few standard functions in Python that are helpful for working with these ASCII character encoding. So ord of x accepts a character x and returns the ASCII character encoding. And we could go ahead and figure out what the character encoding is for different character values, right? You could probably get this from a different website if you didn't like that one, right? But you just Google ASCII character codes and it tells you all of them, right? So it says capital E has code 69, right? Capital P has code 80, capital T has code 84, right? But they should be consistent between different websites. So we say ord of x accepts the character x and returns the ASCII character encoding, and then CHR of x is the opposite. So accepts an ASCII character code and returns the character associated with that ASCII value. So these are just opposite. We would call these inverse functions. But let's think about how they work. So we say print ord of e. So we're going to accept the character e and figure out the ASCII character encoding. And it says 101. So let's make sure that that's right. So if we go to 101, and indeed that seems to line up with the lowercase e. So hopefully that's clear to you. And then we could say print ord of g. Well, that would just give 103, right? It's like 2 characters later down in the alphabet. So its character code is 2 higher. But what you have to understand is that the uppercase and lowercase letters have different values. So ord of capital G would be 71. Okay, ord of the number 4 would be 52, and we can verify that here, right? If we scroll over to 52, it lines up with the digit 4, right? And then we can say f equals ord, so this would be example of a function reference variable, right? And then we could say print f of dot. So what's the ASCII character encoding of the dot? And it says that would be not 32, so it would be 46, right? 46 is the dot, and then I guess 32 is the space. So we said print ord of space, and we got 32. Print f of dot, we got 46. Print f of $sign, we got 36. And then we can go the opposite way. So we can say f equals CHR. So CHR of x accepts an ASCII character code and returns the character associated with that ASCII value. So if we say print f of 100, well, it says that the character with the ASCII code of 100 is D, right? So if we go over to 100, indeed, we see that that corresponds to a lowercase d. And then print f of 105, we get lowercase I. Print f of 66, we get capital B. Print f of a val of the string 81, we get capital Q. Print f of ord of 2, well, that just gives 2, because we said ord and f are essentially inverse, right? The ord will take the 2 into a character encoding, but then f will take the character encoding back to the character, and it's a one-to-one relationship. So if you do print ord of f of 99, you just get 99. There's one more function that I want to talk about in this video, one more standard function in Python, and it's called zip. And in order to understand zip, we have to remind ourselves how the enumerate function works. I think it will be helpful to do that. So remember, enumerate of x is a generator that accepts an iterable and returns tuples, right? So it's like 0 and then 0 and then iterable of 0, okay, basically, and then 1 and then iterable of 1. But basically it gives you these little tuples, and each of the tuples only have 2 elements in them. One element is the index position, the next element is the in the next element of that little tuple is the item, the object that was occupying that index position, right? So if you did like enumerate of 4 and 3, well, basically that would go ahead and yield the tuples 0, 4, 1, 3, right? Because 4 is at index position 0 and 3 is at index position 1. We also think about the zip function. So basically zip of xy. So zip of xy is a generator that yields basically, what does it yield? So basically it yields tuples where the corresponding elements, so basically tuples are 2 elements long. Okay, the first element is a corresponding element from X, and the second element is a corresponding element from Y. Okay, so basically I think it would help to see an example of this. So what we're going to do is we're going to create 2 tuples on lines 276 and 277. So A equals 592, B equals 10, 20, 30. And then we're going to say print zip of AB, and it just says zip object at 0x7f, right? It's like a hexadecimal representation of the hash code or something like that. But we can see this is a generator, and we said generators don't return anything, okay? They themselves are not iterables or lists or tuples, okay? So you either have to use a for loop with them, or you have to convert it. You can say list of zip of AB, or tuple of zip of AB, or set of zip of AB, or frozen set of zip of AB. So what we're gonna do is we're gonna say print zip of AB, right? And we just get zip objects. But then what we're gonna do is we're gonna say for K in zip of AB, print K, and that would basically give us 5, 10, 9, 20, 2, 30, right? It's like these corresponding matchups, right? The elements at index positions at index position 0 were 5 and 10. The elements at index position 1 were 9 and 20. The elements at index position 2 were 2 and 30, and that's why they get clumped together in these tuples, right? And then we could also say print list of zip of AB, and that would give us a list with those 3 tuples in it. And then we could say print frozen set of zip of AB, and that would give us a frozen set with those 3 unique tuples in it, right? But presumably, if you had 2 tuples that were duplicates, then the frozen set would be shorter than the list. And then we could say my index positions equals list of range of 10. So basically, what would this list be? This would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can say my elements equals 70, 75, 72, 68, 66, 64, 73, 81, 79, 72. And then we have a couple of things going on here. So anyway, so we said on line 295 and 296, we said print list of zip of AB, and it gave us a list, and then print frozen set of zip of AB, and it gave us a frozen set with those 3 tuples in it, right? It's just sort of index position wise, right? Like at index position 0, you had a 5 and 10, so you clumped those together. So hopefully that makes sense to you. But what we're going to do is we're going to say basically my index positions equals list of range of 10, my elements, and then the elements, I already read them out. And so what we're going to do is we're going to say print list of enumerate of my elements, because we said basically the enumerate generator yields tuples, right? So this will be a list with the tuples in it. So at index position 0, we have 70. At index position 1, we have 75. At index position 2, we have 72, and so forth, right? We talked in lesson 24, I think, about the enumerate generator. So maybe I'll include a link to that video in the description for this video, just that you can go review. But the point is that list of zip of my index positions with my elements seems to work the same way. So it seems like if you say enumerate of X, it seems like it works the exact same way as zip of list of range of length of X with X, right? And that's why we have to say all these functions, right? Is because you would have to be thinking about generating a list. You'd have to think about generating an iterable, and you would be pairing up each of the index positions, like each of those 0, 1, 2, 3, 4, 5, those simple integers with the elements that occupy those index positions. But the point is that enumerate of X works the same way as zip of list of range of length of X with X, right? But the point is that you don't just have to pair index positions with elements. You can pair anything you want, right? So you could say B1 equals basketball and apple, right? And then you could say B2 equals 5 and 2, right? And then you could say print what if you do set of zip of B2 with B1? So then we could go ahead and see what would be the result of that. So then if we go ahead and run it, we get 5 with basketball and 2 with apple. So hopefully that's clear to you. That's our understanding of the CHR and ORD and zip functions, and that was the goal of this video. From UMails03, thanks for watching, and please subscribe.